All right. So the reason why I wanted to do an episode on Yocto was that in the last 5 or so years, we've seen a lot of accidental IoT engineers, people who kind of prototype something on the Raspberry Pi and they managed to get some success. Maybe they had a Kickstarter that really took off. But what a lot of these people don't know is how you manage devices at scale. If you just take Raspbian or Raspberry Pi OS, package that and ship that out to your customers, you're down for a world of pain. Trust me, I've been down there with Screenly. It's not pretty. You end up writing a lot of logic, and we ended up writing a ton of logic for trying to do device management properly. Eventually, we moved to Ubuntu Core. Yocto is a very good alternative to that. What Yocto gives you is a framework for building disk images, but then it has a wide ecosystem that can take care of device updates using things like A/B partitioning schemes, which is considered best practice. So it has a really good, mature ecosystem for using how to build and scale the IoT devices. So this is why I wanted to do an episode of Yocto to save a lot of people from the time and agony and what we wasted on trying to solve this ourselves. So if you're looking to do some kind of project, look at Yocto. If you want a hosted version of this, there are plenty of companies that provide services around Yocto. Balena is one of them, which I've had an episode before on. So do take a look at that. And now on to the show. Welcome back to another episode of Nerding Up with Viktor. Today I'm joined by Joshua and Ross, and we're going to do a talk all about Yocto. So I guess if we can do a quick round of introduction to maybe start, Joshua, if you want to start giving listeners kind of context before we dive into the deep world of Yocto, about who you are, backstory, and how you got into Yocto, maybe.
Yeah, so my name is Joshua Watt, and I'm a software engineer for Garmin, primarily working on embedded electronics for boats. And I've been involved in Yocto since about 2016. And I've been on the Open Embedded Technical Steering Committee and the Yocto Technical Steering Committee along the way. And so that's my background with the Yocto Project.
Amazing. Thank you, Joshua. And Ross, you have wealth experience in this world as well.
Yeah, so I'm Ross Burton. I'm a software engineer at ARM. I'm in the distros team, so we work making sure that ARM stuff works on distributions. So I'm one of the Yocto guys. I've been working on Yocto for off and on 20 years now, which is kind of terrifying. I just looked when my first commit, and it was in 2005. There were some diversions along the way, but yeah, it's I've got like commit number 11 or something in the Poky tree.
Impressive. I want to start the conversation off with like giving perhaps people who are not even familiar with Yocto. If you lived in embedded or in the IoT world, I'm sure you've at least heard the name Yocto and come across it. But for the people who are unfamiliar with Yocto, what is Yocto? Like what does it solve for, and why does it exist in the first place? Like I'll leave that up to you to want to pick that to start it off.
Well, I suppose the usual answer is Yocto is not a Linux distribution.
Right.
It lets you make your own Linux distribution. So very useful for embedded or automotive or industrial situations where Red Hat may not be suitable. So you can take Yocto and customize it, and it's designed to be super flexible. So you can trim it down and make exactly what you need to do. It's interesting. It's definitely got a lot of interesting features which a lot of mainstream distributions don't have, specifically for people that are productizing whatever they're making at the end of the day.
Right. So just to recap that, it's rarely used for the context of I got my desktop, I want to run Linux on it. It's more for I have some kind of PCB with some kind of architecture on, and I want to create a custom distribution of Linux that runs my software, essentially.
Yeah. Yeah, you see it a lot in like consumer electronics, or like deeply embedded things. Like I'm sure Garmin, Josh can talk about some of the things that they make. Like our TV runs Yocto, printers, soundbars, but also you find it in like infrastructure. So sort of you find a lot of telecom backends would be running on Yocto hardware, or like big data centers might have BMCs which are built with Yocto. So yeah, the full stream, micro all the way up to data center scale.
But we have, I guess, it's not really for super low end devices or low resource devices. It's slightly more. It's not for single board, or sorry, single board is not the right word. It's not for like the lower end of the spectrum where you have like RTOS and that. So it's a tier up from that where you're running. So x86, ARM, and so on is largely where, or I guess RISC-V these days is where a lot of the boards are running on, right?
Yeah, and PowerPC and MIPS.
Right. Yes.
We still have people using that hardware because once you ship something, like a lot of deeply embedded vendors, they may make a product 15 years ago,
right?
And they still support it, so they're still using Yocto and they're still shipping this hardware, which a lot of people may think is, to a lot of us, it's dead hardware, but it's got a lifespan of 2 decades. So, yeah.
In particular, if you talk about more specialized hardware, right, or special appliances, I guess they have much longer life cycles than your consumer hardware, of course.
Yes, that brings interesting problems.
Yes, interesting. So, I guess let's unpack some terminology in the Yocto world. At least for me, when I first got involved, I mean, I've touched Yocto quite a few times over the last 10 years, but I never really got super deep down the rabbit hole. But I've built images using Yocto a few times. And I had to definitely. I wrote a blog post a few weeks ago that kind of caught up about how to use SBOM, which is why I got re-engaged in the Yocto world, and that's how I got in touch with Joshua actually because he was helping us in one of our CISA working groups about how we actually do SBOMs in that world. But when you start exploring Yocto for the very first time, it's a pretty steep learning curve. I don't think I think it will be a lie to say that it's just plug and play and you just got to figure it out in 15 minutes. There are a lot of things to figure out. I mean, where should we even start? Maybe open embedded, Poky, BSPs, recipes. I mean, there are, these are not intuitive concepts, I guess, until you get pretty deep down the rabbit hole. How do you guys best explain the fundamental core concept, if that makes sense, in Yocto?
All right. We can skip over the entire Yocto versus open embedded thing because that's partly historical.
Okay.
And most people don't use that. You can use the terms interchangeably, even though they do identify entirely different things.
Okay.
BSP is a board support package, which is I consider it a historical term. It doesn't really make any sense these days, but it's the configuration and the port for a particular target device, be it a Chemu machine running on your laptop or a particular piece of hardware. On my desk, I've got a TI Beagle Play, so there's a BSP that targets that. Then there's distros. So we have Poky, which is the reference distribution, which is an example which you should not use in production. It turns everything on for testing purposes, including stuff like you can log in without a password, which is useful when you're testing stuff, but less useful in shipping hardware. So it's a good starting point, but it should definitely be customized at least, or ideally rewritten to match your use case.
Right.
What other main concepts are there? Individual recipes.
Yeah.
Build up. So there's a recipe for the kernel and a recipe for the compilers. and your applications may be built out of multiple recipes. They build packages which are then combined to make an image, which is a thing you normally put on your target.
Right.
So that would be a disk image or something.
And I think it's important to kind of note here that everything is built from source. So you're not pulling in packages. When you say compiler, you basically mean we're building everything from scratch, like fully. Like, well, I guess you are bootstrapping using the compiler on the host, so you're not building the compiler for the compiler, but you're basically starting with everything from source and building everything from nothing, essentially.
Yeah,
yes.
Build the cross compiler for you, and then use it to build all the stuff that goes on the target. So the host dependencies that are required to get started are pretty minimal. It's GCC, bin utils, a couple other utilities, but you don't need any cross compilers or anything installed because we're going to build those for you.
Right. And I guess it goes without saying, starting from scratch without a cache takes quite a while. In particular, if you're cross-compiling from a different one architecture, another architecture, right? But even within singular architecture, it takes quite a while to build everything from scratch. Right. So Poky, or Poky, whatever how you guys pronounce it, Poky, is the reference. If you look at documentations online, I think a lot of people would just use and ship that for a lot of distributions. I guess one of the things I'm curious about there is kind of like horror stories, what you guys have seen in the world of just like, I'm just gonna repackage this and zip it out on a device completely insecure. Like, what have you guys seen? I'm sure you must have seen some terrifying things in that domain.
I don't know if I've seen anything like personally, but I have heard of people mentioning that they still ship with Poky, and it's like, well, that's terrifying.
Right.
I don't know if I've actually seen anything directly though.
There's a fairly regular presenter at one of the Yocto conferences called Marta, who does security work, and she has some horror slides of like unnamed devices, but they accidentally left on you can log in without a password.
Oh wow.
The customization thing is kind of very important. I was actually looking through a license manifest for an unnamed vendor this morning, trying to see, does this thing I think use Yocto? So
right.
The usual trick is find the GPL compliance document and look for particular things like, oh, that's one of our package names. So yes, right. This thing runs Yocto. Going down it, now this is a data center infrastructure piece, and it's shipping a 4x server, and there's looking through the list. It's like your security vulnerabilities are magnified because you're shipping everything instead of saying this is a tiny piece of computer that doesn't need to have a display. Let's not ship an X server. So you do see silly things like that occasionally. But yeah, the entire oops, I accidentally used Poky as my production device is something which we've been aware people do and shouldn't be doing. So the latest release puts up a very big message every time you log in saying this is for testing and development purposes. Do not ship me.
Right.
So hopefully we won't ever see that in production.
That's okay. Fair enough. So when people get started with Yocto, what are some most common, I guess, misconceptions in like using Yocto, and like what are the biggest maybe mental hurdles to get like your head around Yocto as a concept?
I think one of the things that tends to be confusing early on is the relationship between recipes and packages and your final root file system, which is that like a recipe's purpose is to pull in your source code and compile it into packages. Like, and these are, we've got a bunch of different packaging formats, but it is like the same concept as like a deb or an RPM or whatever type of package, binary package that then gets installed into your root file system. I think that can be very confusing at first because it's kind of, it feels like it should be more direct. Like you take a recipe and that's what ends up on your root file system, but there's actually an intermediate step of packaging there, and not necessarily all the packages that a recipe produces are going to end up on your root file system. So I think that can be confusing early on.
Yeah, definitely. You see a lot of people confused about how they built a recipe and it doesn't appear on their target because you just built it. You didn't put it in the image.
Right.
Or conversely, trying to figure out how to make things smaller. It's like just stop installing the things and it won't be there. It does seem a bit complicated, yeah.
Yeah. I guess one of the things that I found confusing was, I mean, Joshua, you kind of alluded to it, that there are different packagings. Like in the config file, you can say like, oh, I want RPM, I want deb files, or there are some few other ones. I think Alpine packaging is support as well. I think some other ones, right? I, by that, kind of inferred that it becomes like Red Hat E or Debian E, but it's completely unrelated to that. It's purely just, how do I get this package into my system, more so than anything inferred into the actual system. I think that was, for me at least, conceptually confusing.
Yeah, and I don't know the history of why we have all the different packaging formats, but we do, and there's definitely been talk about adding more, like APKs, for example. There's been some discussion on the mailing list about that. But yeah, that can be confusing because it's like, I'm producing an RPM. Why can't I just point it at the, Fedora RPM repos and install stuff? And that's not the intent. They are RPMs, but they are in no way compatible with anyone else's RPMs. They're just, that's the format that you want to distribute your packages in, and that's fine.
Yeah. And yeah, for me, like I incorrectly assume that you're using, like, that is basically the base image you're using, essentially derived based on the packaging format, to use different base images, but it completely has nothing to do with that. So that at least threw me off quite significantly when I started playing with it. So you've now built your Yocto image. You managed to kind of create something that runs, right? Let's assume you have not used Poky and you have actually tightened the ship a bit and you actually use it on its production grade. The next thing that I've seen a lot of, I guess, issues around Yocto is around OTA, right? Because once you ship a device into production, great, but that's just the start of the journey. That's not the final piece, right? You need to, like, if there is a CVE out there, you need to be able to say, oh, I'm going to make sure that these devices are updated for, in particular, going back to the previous point about, oh, this might be a 15-year life cycle on this device, right? Like, how do I update these devices in the wild, or at least provide a mechanism for that can be done manually over that duration? So let's switch topic to like OTA, maybe not even OTA, but like updating mechanisms a little bit in Yocto, and like, how does that work?
Well,
okay, I'll go.
Yeah, go ahead. Yeah.
So basically, this is another one of the places where Yocto says, this is a complicated topic. There are lots of variables. You decide.
Right.
So by default, we produce packages, and you can run a feed server and just run apt update if you want. But in for like your random laptop, that's fine. But for something you've deployed to 1 million houses, less ideal.
Understatement.
Yeah. So there's a number of options for proper, like, battle-tested updaters, and I can think of like 4. There's sort of Mender have a son.
Mm-hmm. That's the OG one, right?
Yeah. SW update, Rauk. There's at least 2 more. I can't remember the names off the top of my head. And they all are fairly solidly integrated into Yocto. A lot of them have companies behind them doing like commercial support. So it's a choice of sitting down and saying, what features do I actually want in my updater? And then finding the one that fits, because they do have different feature sets.
Yeah.
But yeah, it's a tricky problem, but it needs to be approached carefully, because you don't want to actually brick a fleet of devices.
Nor do you want to ignore that problem and try to kind of shoehorn that into a product after go live either, right?
Yeah. it's something which several years ago we were thinking, do we need to actually provide like integrated into the core an OTA updater?
Yeah.
But it didn't take a huge amount of research to realize that it's a very broad problem, and I don't know if it's feasible to say there is one answer, because
That's fair enough.
And I think it does succinctly highlight one of the great advantages of the project, which is that there are all these third-party layers that do this very well, and they're very easy to integrate, or relatively easy to integrate, and then you have the choice to use what works best for your product without too much hassle, or people are able to support these things independently without much hassle. So that's a great strength that we have with that.
Yeah, being agnostic is definitely a strength in some ways, I would say. But I think at least if you're old school, you've been around embedded for a long time, OTA and these things, they are kind of like table stakes. Like we understand that that's like a hard requirement before you even like put together a spec for a project. But at least over, like, I guess with the rise of the Raspberry Pi in particular, like you have a lot of people like, or became like accidental IoT people, if that makes sense. And I'm one of them, right? With Screenly, like we would become like an accidental IoT project. And much to your point earlier, Ross, about like trying to do like deb package updates in the wild. Like this is the path we took on the Raspberry and back in the days, like try to script that and do that at scale. And it's a world of pain, right? It is like the amount of fallback and logic you need to do to wrap around that is just insane, particularly when you factor in that the power might be cut any moment because these are devices that you have no control over. It's not a data center, right? So I guess highlighting the need for OTA is something that would save a lot of people a lot of pain if it's like really properly, I guess, instructed up front, really, that, oh, do not even contemplate go live without a strategy for OTA. And I guess that's kind of a natural segue over to one of the other things I want to talk about, which is supply chain security and like security at large in the embedded world. And I mean, with the rise of CRA in particular in Europe, it's no longer an option to think about how does the supply chain life cycle for these devices look like. It can't be an afterthought. Like again, like your OTA needs to be the part of your day zero strategy, right? And I'm curious about what you guys have seen from the community with regards to CRA and or EU Cyber Resilience Act for short, really, if those not familiar with it. How that has kind of shaped how people see Yocto and how people use Yocto differently. Like, I'm really curious about how you guys have seen that.
Well, I think people have been more interested in their supply chain. From the Yocto side of things, I think another like thing that's always been really good is we've always had a really good supply chain just because of the way the project works.
Right.
We start with a very minimal set of dependencies. The recipes are pretty exhaustive in like knowing how to build them and having all the metadata information about all the stuff being built. And then we use that to build, your cross compilers, like the tools you need to build the stuff you need to build. And then we follow that through all the way to the final image that you're generating is also described that same way with that same level of detail. And so, intrinsically, we've always had a pretty strong supply chain. And so I think a lot of people that I've seen that are using the project as far as like CRA and stuff, they're not too worried about being able to justify their supply chain in way more detail than the CRA is asking for anyway.
Yeah.
So that hasn't been too much of a concern. It's just been like, how do we get that information out of the project and into something that's digestible by, people or machines or something like that.
Yeah, you definitely have a strength by doing everything of source because there are very few things you need to trust right outside of that, which is great. But I guess that really again highlights the need for OTA and being able to like, if you like now you know what version you're running and what license it has. That's a fantastic starting point, but it's the start of a journey, not the end goal, right? So on that, I mean, kind of jumping a bit here, but like we talk about building a bit, and how far is Yocto to fully deterministic builds today? Like, is it possible to do full deterministic builds on the system today?
I think if you're talking, I mean, the thing to keep in mind is when there's lots of different layers, right? With varying levels of, third-party layers we don't necessarily have as big a control over, so it does depend on what software you bring in.
Yeah.
But as far as like the core stuff, I believe we're fully reproducible, or at least try to be fully reproducible as much as we can. There sometimes are points in time where we're not, just for reasons. Some package upgrade did something, but usually we're working on fixing it. And we do track that. There's a page on the website that tracks the reproducibility status of the core layers. And that's supposed to be binary reproducible. So you build it today, you get a binary output, you build it in 2 years. As long as you start from the same place, you should get the same binary output. And kind of the way that's structured then, in order to sort of allow end users to cover third-party stuff, is the way that those tests are written is designed such that you can run them against your own stuff and not just core. Right. So what I always tell people is, like, we've made sure that core can be reproducible, but if you care about reproducibility, you need to be running that test against your stuff and make sure that your stuff is reproducible. Right. Because like we can't guarantee your thing is reproducible, but we can guarantee that the core stuff is. Of course. So that's kind of how that works as far as reproducible builds goes.
Okay, that's very cool, because that's a big upside with regards to supply chain security as well. Like if you do have a reproducible build, so that's a big one. Let's dive into kind of like the second big meaty piece I want to talk about in today's call, which is basically how Joshua and I first met, which is around SBOMs, really. And Joshua, you have written much, if not most, of the SBOM parsing inside of Yocto. So maybe let's start, before we dive into the nitty-gritty details of why and how this is done. I guess we have the philosophical debate of SPDX versus Cyclone DX. How did you guys land on the SPDX? What was the debate internally? I'm curious.
Well, there is the Linux Foundation connection with SPDX, which factored into it fairly heavily. I mean, that's most of it. Like I looked at both of them, and SPDX kind of made sense. And then the other thing that was really helpful was we knew that, so when we started, SPDX was on version 2.2, but we knew that they were working on 3.0.
Yeah.
And so the plan from the beginning was always, we're going to do SPDX 2.2. And we know our supply chain is very complicated. And there's a good chance that we're going to want some more things added to the SPDX standard. And so being able to do SPDX 2.2 and then be involved in the design and the development of SPDX 3 was extremely beneficial, because we were able to help guide SPDX 3 to like really understand deep build supply chains, which is what we have. And then also, we were able to help make sure that whatever came out of SPDX 3 would align with what we wanted to say, about our SBOMs. So that worked out really well, just for those reasons.
Yeah. And what's the status on SPDX 3 support in Yocto at the moment?
Yeah, so SPDX 3 was added in, let me see here, the 5.1 release, which is codenamed Styhead. And that was released in October 2024, and it's the default now. Okay. There's not so the next LTS release of Yocto will be SPDX 3 by default. You can still use SPDX 2; you can turn it on, but we are SPDX 3 describes our system much better than SPDX 2 does. And so we very much prefer that people use that just because of how much better it works for our use cases, because we were involved so early in the design process of it.
Right. The thing that I thought was really fascinating when we kind of did a deep dive in how you build SBOMs in the first place, it's like it's very different than how you build SBOMs normally, by virtue of you being kind of like a package manager, right? Or package builder, I guess is a better phrase for it. So maybe let's take a path down that road and just talk about like how do you build SBOMs and like what allows you to build SBOMs, I guess, in a far more complete way than almost anybody else I've seen out there, because you can make assumptions that almost nobody else can make, right? So yeah, take a deep dive path down that road.
So because we're building everything from source, our recipe files and the build system, they have to know everything about how to build it from source, right? So you need to know the build time dependencies, you need to know the runtime dependencies of things, of the packages that you're producing, and that needs to go all the way back to, the cross compiler, right? And we've always been very good about tracking license information and things like that, because that's something our users have cared about since before we had SBOMs. Yeah. And so, the breadth of information that we have, is very deep. Like we can checksum all the source files that went into a build. Because one of the other things that we've just pretty much always done is we've had very good build hygiene, making sure that every recipe that we're building is in its own little build silo. And so it's not leaking out and pulling in random stuff that it shouldn't be from other places, as best we can. We try really hard to do this. And so we have a very, very complete picture of what it takes to build stuff. And so, the SBOM support is primarily an exercise in taking the information we already know and putting it into a different file format. It's more complicated than that. I don't want to trivialize it, but it's not a ton of Python code, right? It's it's not that bad. So because we already started from such a good place, it made it pretty easy for us to end up with these very high quality and very complete SBOMs. As I say a lot, it's quite easy to have an SBOM that's 10 times the size of your final root file system if you turn on every single feature. I want to checksum every file and every build and every file that ends up on the root file system. You can get a very large SBOM. Order of magnitude larger than the actual binary you produced at the end of the day. So very complete if that's what you're going for. We do have knobs to adjust the levels because not everyone wants that. And can be a lot.
And how do you, so you mentioned you're capturing hashes, you're capturing build dependencies, runtime dependencies. That graph is very complex, right? So I guess, is there anything missing at all? Or do you literally capture everything that you capture in build time in the SBOM more or less from your artifacts?
It's pretty complete. I'm trying to think if there's anything in particular that's missing. I can't think of anything off the top of my head that we have. So with our SBOM support, one of the choices that we made was we do what's called, or what I like to call, we capture first principles things, which is stuff that we are authoritative on because we're the ones doing the build. So we try to avoid heuristics and things like that. You might see other SBOM tools might do a scan of a binary and say this is probably in there, and that's fine. There's certainly nothing wrong with that. But just because of where we are at in the supply chain, we kind of just take this first principles approach, or we're reporting on the things that we know about because it's in the recipe or whatever, we know. And then you can layer on top of that scanning tools that do other stuff, right?
Sure.
But it's not really worth it for us to maintain a bunch of heuristic tools in
Right.
Yocto Project. And I can't think of anything. It's generally pretty easy to map the information we have from the recipe or the build system into, SPDX, as long as the property as long as there is a way to express it in SPDX. It's generally not that complicated to do.
Right.
It's just a matter of manipulating the data around and restructuring it into the right format.
And with regard to, go ahead, Russell.
Sorry, I was going to say, one thing we can do, which I think a lot of people may miss or other systems can't do, is because we build all the software from scratch, we can pick up statically linked libraries as well. So if your binary statically links to some compression library, it won't be obvious externally or in the package dependencies, but because the SPDX aggregation happens during the build, we can look at the debug symbols and go, oh, look, it's got a statically linked copy of zlib, and that can go into the SPDX, which will be hopefully very useful next time there's some tragic CVE involving a really low-level library that has been statically linked everywhere.
Right. And you also know the version because it's sandboxed inside of the build version, so you really know what it's statically linking as well.
Yeah.
The only thing that I guess is missing, I'm just putting the working group with its CISA hat on, is it's like the supplier information, right? Is there a way to infer that if you are day job, can you implement that as part of the Yocto toolchain? Say this Yocto image was built by Garmin or ARM or whatever, and can you supply all those information as well as part of that build cycle to get to a full augmented SBOM as well, or is that outside the scope of the tooling?
Yeah, so if you're specifically talking about there's a field in SPDX called supplied by.
Yeah, the top level.
Yep. So you can set that. There's a variable, a bitbake variable you can set in your local conf. Usually is where you'd set it, right? And you can set the supplier for your packages, and it'll just show up in everything you build then.
Right.
So that's definitely possible. You can also do, if you're talking about who did a build, right, which might be different than the supplier, right? So you can capture that information too. I believe it's off by default, but again, you can turn it on, and that's what I'm talking about with all the knobs that are in the stuff. There's a lot of options to turn on more output than are on by default. The defaults tend to try to walk the line between build speed. The more stuff you turn on, the slower it's going to go, right?
Sure.
So they try to walk that line between build speed, and then also the default that we have is to do reproducible SBOMs, because there's definitely features you can turn on that will make them not reproducible, like precise build timestamps and stuff like that.
Right.
So yeah, but again, that field exists, that supplied by field exists in SPDX, and we do have a way that you can set that. I believe it's just off by default.
Yeah. No, I guess what I'm hinting at is the NTIA minimum element compliance element of it, right? Because if you're supplying particular embedded hardware to the US government, for instance, you probably do need to meet these guidelines, right? So that's where those pieces become more important, I guess. The next thing I kind of want to cover, which is on kind of tangent this, but very much related, which is the VEX side of things. And I know, Ross, you've been doing some work on the VEX side of things, a little bit touching there. So I guess, and you both obviously are involved indirectly or directly with the work around this. So maybe how that's the whole concept of VEX. Well, maybe if you can explain to the listeners, what's a VEX file and how does that come into play with the SBOM? Maybe we can start there.
So I suppose we start with a little bit of history. In the previous releases, we had a tool called CVE Check, and that would download the NVD database and just try and compare your recipes with the database and go, oh, here are some CVEs you should probably know about. These have been fixed. These have been these are still unmitigated. these are invalid. And that produced an output in sort of machine-readable text and then JSON, which is fine, but it's all very bespoke, Yocto-specific tooling. But there's lots of limitations there. It's a one-time report.
Right.
So, it's a snapshot of the state of the CVEs at the time that you did the build, which is not very useful 2 months later.
Right.
So we've been looking at improving that situation for some time. And there's tangential drama with the CVE community, which probably should gloss over today. There's an entire episode on its own. But we are now, thanks to some epic work by Josh, we can dump the full set of CVEs that we know about into the SPDX directly. So we don't generate a separate OpenVex file, because the SPDX is slowly becoming like the one source of truth about your build.
Right.
It's not just your SBOM. It's also every package contains this file list, and these files are of these sizes, and so you've got all the actual per file metadata, and also now, and these are the CVEs that at the time of the build we knew about. So we can say, this issue, we fixed it with a patch. So then in a year's time, you can use a tool to process the CVE data that you have in the SPDX. Right. And then you do an up-to-date scan. This is, at the moment, work in progress. There are bits of tooling floating around. There's a Yocto Vex check tool, I think it's called, which mostly works, but I don't think it scans the latest files that we've got. So that still needs a bit of work. But it's coming together, and it looks like in the next release we'll have all this all sorted out, which will improve dramatically. I just want to run a CV scan across my software store,
right?
Without using any external tools.
And it is really tracking that over time, right? Like a SBOM is a great tool for that, but then it's a truth in time, not like a absolute truth forever. Like I have 0 CVs, right? Or whatever they will be called in the future. Now that CVs are semi-gone. Or yes.
Let's not go there.
Yeah, let's avoid that. But so the idea then is you can generate this dump basically as an artifact of your work, Joshua, from the SBOMs. And then what's the relationship with upstream source and Yocto source, right? Because you're pulling in upstream, but I presume there are sets of patches involved. You're not just pulling master from upstream repo, you're applying a set of patches for insert reason, right? How does that look in particular from a vantage point of vulnerability patching and even I guess backporting patches, because I presume that's something that will kind of fall on the Yocto project as well, right? Not sure who of you feel closer to that can of worm.
We do apply patches for sure, and there's the way that patches are applied. There's a tag you can put in the patch that says this fixes a CVE, and then the build system will see that and report it in the CVE statuses for the things, and then that ends up in the SPDX output. So it's pretty easy from a mechanical perspective, as long as the patch exists.
Right.
It's pretty easy to apply that and get that to show up in your build output, and then get marked as fixed, basically. So that's kind of how that works.
But do you guys run a situation where you have to backport as well, or how does that? Because I would imagine that's a scenario that is very real, particularly if you're talking about life cycles of 15 years of a device. What's the LTS window, by the way, for Yocto? What's the support window for an LTS release?
LTSs have a 4-year cycle.
4-year.
Yeah, so that's 4 years from the Yocto project itself. Obviously, if you're producing hardware which you want to last 15 years, then either you need to maintain it yourself, but there are plenty of ISVs who will, give you a supported Yocto derivative for like 10 years or more.
Mm.
Yeah, we do backport a lot of patches. As Josh said, if the stable releases tend to only get security fixes or like pretty serious bug fixes. So when patches do get taken back, they all need to have a little CVE tag in the patch identifying what CVEs were fixed.
Okay.
And yeah, that just bubbles through.
Okay. Interesting. One thing I really like about this whole approach in general with the SBOMs and how you build things is that you kind of hinted at it before, but like you're solving for the problem of unknown unknowns, which is very real in the world of SBOMs, because if you point any of these modern tools out there like Sneak Trivy or any of these tools to generate SBOM, they're just basically, if you talk about an image, for instance, they're basically just like reading the package database and then building an SBOM based off that. It's not very difficult to circumvent that by either modifying the database or just chucking a binary in there that is not even picked up by these tooling. So that's one of the things I really enjoy with the approach for Yocto and how you guys are doing that, because it feels like one of the few tools out there that are like proper complete with regards to SBOM generation, and I guess Zephyr is another project that is doing well with regards to that from a slightly different angle, and maybe that warrants another episode of going down the rabbit hole of Zephyr, which is completely different. Guys, this has been super interesting. I think I've covered most of the things I want to cover in today's episode, and I think there are a lot of really interesting nuggets in what you guys have done. And for people who want to get started with Yocto, people want to learn more, what do you guys recommend to avoid the common pitfalls and kind of get started the right way?
Well, I'd start by going to yoctoproject.org. Also, the documentation from there is good. If you start with the quick start guide and don't click on like full manual, because you will get blown away. But the full manual is immense, but the quick start guide is a few pages, and that will get you started. And just treat the rest of the full manual as a reference, not something you go to bed with to read. Also, because we're an old school community, so if you want to chat with people, then we're still on IRC. But there's an active IRC channel on LibreNet. It's #Yocto. So yeah, come there, have a chat. If you've got any questions, we're friendly.
Very cool. And what's next on improving the security posture in Yocto in general, and what's on you guys? What are you guys excited about on the roadmap going forward for the next year?
I'm not sure if excited is the word I'd use, but the CV situation is something that, well, I committed to working out the CV story for the next milestone, which is like the next 3 months, about a week before the drama all kicked off. So I'm regretting my life choices there. But hopefully we get some stability and we understand what the future is going to involve. So that needs to be improved, and the new tooling written to just have everything in the SPDX and generate reports from that is where we're going to be going shortly. Right. So anyone who's been using the CV check tool will probably be aware of its limitations, and hopefully the new tools will just replace that really nicely.
And that's before you rewrite everything in Rust, yeah?
No, don't get me started on Rust.
Joshua, what's on your agenda? What are you excited about for the roadmap?
As far as the SBOM support, we're definitely looking at doing the VEX reporting. That Ross is talking about. I was trying to think if there was anything else major We're still heavily involved in I'm still heavily involved in the SPDX community. Also, they're working on their 3.1 release. So there's a couple things that we're looking at there to just make it better. In general, I can't remember any specifics off the top of my head, but there's been a few things that's been like, we could do this a little better, and so we should do that. We're planning on, we'll probably be an early adapter of SPDX 3.1.
Well, there are not that many tools out there that even do 3.0 yet. So I think you're very early on in that regard.
Yes.
Good. Well, thank you guys so much for coming on the show. I very much appreciate it. And I hope people learn quite a few things about both Yocto and about, well, SPX, and as well as using SBOMs in the embedded world. So again, thank you so much, guys. Have a good one.
You too.
Cheers.
Thank you.
Cheers.